want to graph a parabola of the form y is equal to ax squared plus bx plus c given rational coefficients. And I really think that the purpose of this type of problem is just to increase frustration among students. You already know how to graph a parabola given in standard form. You already know how to graph a parabola given in vertex form. You already know how to graph parabolas. Here, we're trying to make sure you know how to handle fractions. Right? Okay. So, I'm going to do this two ways. First, I'm going to complete the square to find the vertex. So y is equal to negative 5/4. I have to factor that out of x squared plus, minus. See, and here I go already making sign errors. Minus 8x. Negative 5/4 times negative 8 is positive 10, right? And then plus some box that makes a perfect square. And then I have minus 15 out here. Now I subtracted 5/4 of this box, so I have to add 5/4 of this box back in. And what goes in the box? Half of this squared, so 16. Okay, so this is negative 5/4 x minus 4 squared, and then this is negative 15, and this is positive 20. So plus 5. My vertex is the ordered pair 4, 5. And then I want to substitute in, let's see, 1, 2, 3, 5, and 6. And I'm not even going to do all that and deal with all the fractions. So you would put these values right here in here, and then you need to use the function in ALEX, the button in ALEX that allows you to type the ordered pair rather than clicking on the point, because you're going to end up with a bunch of fractions, which are a pain to graph. The other way to do this is to know that the vertex happens at this point. Right, that is the ordered pair. So given the original, let me write this, let me get where I can see it anyway. Y, which is the same thing as f of x if it's a function, right, is negative 5/4 x squared plus 10x minus 15. And so negative b over 2a is negative 10 over negative 5/2. And that is 4. And then I substitute in a 4 to find the y-coordinate of the vertex. So y is equal to negative 5/4 times 16 plus 10 times 4 minus 15. This is negative 20 plus 40 minus 15, and that is 5. So my vertex is still at the ordered pair 4, 5. And then I'll choose two values less than 4 and two values more than 4. You want to choose those values equidistant, because remember we have an axis of symmetry at x equals 4 is the axis of symmetry. Okay, so what that means is that these two values will be the same, and these two values will be the same.